this video, we're going to be looking at angle measures and segment lengths. If you find this video helpful, share, like, and subscribe. So in this lesson, we're going to be looking at two things. First is the angle measures, and the second one is the segment length in circles. Okay, so first let's look at angle measures. This is what you call the interior angle theorem. So it simply states that the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. Okay, so let's look at this one. It says that if we would like to find this angle 1, which is actually an interior angle, what we're going to do is just to simply add the intercepted arcs divided by 2. Okay, as simple as that. Okay, so let's look at this example. Okay, let's find the interior angle here, which is labeled x degree is equal to 1/2 of the sum of the intercepted arc 46 plus 90. So 46 plus 90 is going to give you 136. 1/2 of 136 is equal to 68 degrees. Okay, so this is 68 degrees. Okay, let's go for the next one. Here, still the interior angle is given, but one arc is missing. So we're going to go backward on the process. Okay, so let's look at that one. This is going to be given is 35 degrees as the interior angle. That's gonna be 1/2 of x plus your 30 in here. Okay, so I'm going to multiply both sides by 2 in order to cancel the denominator. So 35 times 2 is going to give you 70, is equal to what is left here is only x plus 30. Okay, now let's transfer this one on the other side. So that's going to give you minus 30 is equal to x. 70 minus 30 is going to give you 40. So that's going to be the value of your arc. Now, the best thing to do is to recheck your work, whether it's correct. Now, let's prove it this way. So, is 35 equal to 1/2 of 30 plus our x here is 40. Okay, so 35 still equal 1/2. 30 plus 40 is 70. And we know that the half of 70 is 35. Therefore, we are correct. It means to say that our calculations are correct. Okay, let's go to the next one. This time, let's look at the exterior angle theorem. Okay, so earlier we looked at the interior. This time, we're going to be looking at the exterior, means the outside part. Okay, so here the measure of an angle formed by two lines that intersect outside the circle is half the difference of the measures of the intercepted arcs. Okay, simply said, the measurement of angle 1 is equal to 1/2 multiplied by the difference of x and y. Now here, the x in here is going to be the larger arc, and the y is the smaller arc. Same with this case 2 and the same with case 3. Now let's look at the first case in here. See, the first case is going to be an angle formed by two secants, okay? The second case is going to be an angle formed by a secant and a tangent, okay? And the last is angle formed by two tangents. Okay, these are actually our earlier lessons in this unit. Okay, so let's look at some real examples here for us to understand what we are discussing in here. Okay, so let's look at this one. We are being asked to find the size of W in here. We have this arc in here, so we can actually subtract that from 360. Okay, so 360 minus 110 is going to give you 250. Means to say that this is going to be 250. Now we can recheck if our answer is correct. Okay, 70, is it equal to 1/2 of 250 minus 110? Okay, 250 minus 110 is going to give you 140. So 70, is it equal to 1/2 of 140? Well, we know that the half of 140 is 70. Therefore, our calculations are correct. Okay, let's go for the next one. The next one, we are asked to find the value of exterior angle. So y degree is equal to 1/2 of 110 minus 30. 110 minus 30 is gonna give you 80. Okay, so that's gonna be 80, and 1/2 of 80 is 40 degrees. Now let's try to check it first. Okay, let's recheck. Okay, let's put it backwards. So this angle is gonna be 40. Is it equal to this one? This is going to be 1/2 of 80. So well, it's really true. The 1/2 of 80 here is 40. It means your calculations are correct. Okay, let's look at this time segment length in circle. Okay, so there are three cases that we're going to be looking at in here, but they are actually under the same theorem. Okay, for a given point and circle, the product of the lengths of two segments from the point to the circle is constant along any line through the point of the circle. Okay, so let's look at some cases in here where this theorem is true. So first is the intersecting chord inside the circle. In here, we're not actually interested with the angles created, but we're actually interested with the segment length. So if we would like to find that segment length, we're going to multiply AB is equal to CD. They should be equal. The next case is actually a secant. There are two secants here, a secant line. So if you're going to be looking at this one very carefully, the way it's being arranged is also very logical. So first, if you're going to look at this one, you're going to first put or write the one outside here. This is outside first, then inside multiplied by the one outside. Same with this, outside first and then inside, and then multiplied by outside. This will be equal segment length. Okay, the third is going to be tangent. This is actually tangent line, okay, and a secant line again. So here what we're going to be doing is we're going to square the t in here because it's tangent. But on the other side of that length, that's going to be outside first and then inside, then multiplied by the outside segment. Okay, so let's give you some examples. Okay, find the value of the variable in each circle. Okay, so let's see. Here, earlier I said we're going to equate this one. So first outside, it's gonna be 6 plus the inside 8 multiplied by the outside 6. First, this one again, it's gonna be 7, okay, outside and then inside plus y, then multiplied by outside. Okay, so this is going to be 6 plus 8 is going to give you 14 multiplied by 6 is going to give you 84. So this side is 84. Now we're going to distribute this part. That's going to give you 49 plus 7y. So 84 minus 49 is equal to 7y. Okay, so that's going to give you 84 minus 49 is going to give you 35 is equal to 7y. Divide both by 7. Okay, and we're gonna give you 5. Okay, 35 divided by 5, the 7 is equal to 5. Okay, let's do some recheck. Okay, let's recheck. So This side is already 84. So what I'm gonna do is just going to put it in here. It's gonna be 7 plus 5 and then 7. So are they going to be the same? 7 plus 5 is gonna give you 12, and 12 times 7 is 84. So we are correct. It means to say that our calculations are correct. Okay, next example here. This is like this case number 3. So what we're gonna do here is we're going to square the z is equal to the first one first is going to be outside, and then the inside, and then multiplied by the outside. So z squared is equal to 16 plus 8 is going to give you 24, and then multiply that by 8, it's going to give you 192. Now we're going to get the square root of this. Okay, so what is left now is going to be z. Now the square root of 192 is actually around 13.85. Okay, 856. I'm gonna get at least 3 decimal places. Now if I'm going to check this out, I'm going to correct it. If I'm going to square this one, then I need to get 192. Okay, so we know already that this side is going to be 192. If I'm going to square this one, 13.856 square. Okay, let me just square that. Square, voila, it's 192 over 192. So it's correct. Okay, let's look at this example. More examples for understanding. Okay, first we're going to equate the first one. Here it's going to be outside first, and then the one inside multiplied by the one outside is equal to 16 plus x and then the one outside. Okay, 14 plus 20, that's gonna give you 34, and if you multiply that by 14, this is going to give you 476. 16 times 16 is gonna give you 256 plus 16x. Okay, we distribute that. Now 476 minus 256 is equal to 16x. Okay, 476 minus 256 is going to give you around 220. It's equal to 16x divided by 16 both. Therefore my x here, okay, I'll write it here. Okay, 220 divided by 16, it's gonna give you 13.75. Okay, let's recheck. So we know that this side is already 476, right? So I'm just going to substitute the value of x in here. It's gonna give you 16 plus 13.75 multiplied by 16, 476. 16 plus is going to give you 29.75 times 16 is going to give you 476. Voila. Okay, so our calculations are correct. Okay, next we're going to look at this one. So this line and this line are together, and this line and this line are together. So that's going to give me 6.5 m is equal to 7 times 3 is 21 divided by 6.5 divided by 6.5. Therefore m is equal to that's around 3.230. Okay, so let me just recheck. For recheck, what I'm gonna do in here is, I know that this side is already 21. Okay, so this is going to give you 6.5. It's gonna be 6.5 multiplied by 3.230. 230. Are they equal? Okay, so I'm going to multiply that by 6.5, and that's gonna give you 21. Voila, it's correct. Okay, so given this figure, what is the value of x? Okay, where is my x? The x is actually located in here. Okay, this one and this one. So that's gonna give me 10x is equal to 9 times 6 is 54. Okay, now we divide this by 10, therefore x is equal to 5.4. Okay, now what is the value of y? My y is actually an interior angle, so my y here, y degrees, equal to 1/2 of 85 plus 45. Okay, 85 plus 45 is actually going to give you 130. So 1/2 of 130 is going to give you 65 degrees. Okay, last, what is the value of z to the nearest 10? Okay, here what we're gonna do with letter c here is c squared is equal to, the first one first is going to be outside, that's gonna be 6, and then the one inside, 9 plus 6 is 15, and then multiplied by the one outside. So z squared is equal to, okay, 15 plus 6 is gonna give you 21, then we multiply that by 6, so that's gonna give you 126. Then we're going to get the square root of both sides, so that's going to give you z is equal to, the square root of 126 is around 11.224. 11.224. Okay, so for me to recheck simply is just, if I'm going to square this one, then I'm going to get that number. As easy as that. Okay, so let's find the value of each variable. Let's go for the first one. Here, exterior angle, so x is equal to 1/2 of 160 minus 68. 160 minus 68 is going to give you 92. Okay. And 1/2 of 92 is equal to 46 degrees. Okay, let's recheck. Let's put back together. If this is 46 degrees, is it the same as 1/2 of 92? Because if we have to put that one, we're going to come up with that. Now we know that the half of 92 is 46. It means to say that our answers are correct. Okay, the next one. Okay, here x degree again, so it's saying x degree is equal to 1/2 of 130 minus 30. That's going to be 1/2 of 100, and half of 100 is 50 degrees. Now let's do some recheck as usual. So how do we do that? Put them back together. So 50, is it equal to 1/2 of 100? Yes, it's totally very obvious. Half of 100 is 50. So calculations are correct. Okay, let's go to the next one. Here, there are two variables that we're going to find. So if I'm going to find the value of my x in here, given this angle, I'm going to go backward. It's going to be 50. That's going to be 50 degrees is equal to 1/2 of, that's going to be 160 minus x. We don't know the x. So I'm going to multiply both by 2 to cancel this out. So 2 times 50 is 100. What is left is just this one. 160 minus x. Now I'm going to transfer 1 on the other side. That's going to become positive. 160 minus 100. So x is equal to 60 only. Now let's recheck as usual. Okay, this is going to be 50. 1/2 of this is going to be 160 minus 60. Okay, is it? Okay, 160 minus 60 is 100, and the half of 100 is 50. Therefore, our calculations are correct. Now let's find the value of y. Okay, in here okay, this is, if this is 60, and then we're going to add this together. 160, that's going to be 160 plus 60, that's going to give you 220. And then from 360 we we deduct 220. So 360 minus 220 is going to give you 140. It means to say that this arc is 140. If that is the case, the inscribed angle now here is going to be y degree is equal to 1/2 of 140, and that's going to give you 70 degrees. Okay, that's the solution to this simple problem. Okay, next, this is nice. Segment length, this one and this one, this one and this one. Okay, that's gonna give you 26x is equal to 15 times 20 is going to give you 300. Okay, so x here is equal to 300 divided by 26. That's gonna give you 11.5384. Okay, so if I am going to multiply this number with 26, of course I'm going to get 300. Therefore our calculations are correct. Okay, we have two more. In here I'm going to, this one is 5, so I'm going to solve for my x first. So to do that, we're going to write 5 first. This is the one outside plus inside, and then multiplied by the one outside, and that's going to be equal with outside first and then inside, then multiplied by the one outside. Okay, we're going to distribute that. 25 plus 5x is equal to 15 plus 7 is going to give you 22. Then we multiply that by 7. That's going to give you 154. Okay, so here 5x now is equal to 154 minus 25. Okay, this is going to be minus 25. Therefore, 5x is equal to 154 minus 25 is gonna give you 129. And then we divide both sides by 5. Therefore, our x is going to be around 25.8. Okay, so let's recheck if that's gonna be correct. Okay, so let's see, we know that on this side we already have 154. Yeah, let's just prove if it is correct. So 154, is it equal to this one? I'm gonna put that in. 5 plus 25.8 multiplied by 5. Okay, is it 154? So 25.8 plus 5, that's gonna give you 30.8 multiplied by 5 again. Voila, it's the same, 154. So our calculations are correct. Okay, so here's the last one. Oh, not yet. We still have to find the y. Okay, here. So let's find the y in here. The y in here is gonna be y squared is equal to the first one again, 5. I guess we already have this one. This is going to be 154. Okay, we already have the data, this one. So what we're going to do is just to get the square root of both sides. So that's gonna be y is equal to the square root of 154, and that's gonna give you 12.441. Okay, okay, very nice. So here's the last problem for this video. Okay, so how will I do this? Now I have this one, so I'm going to first solve this one. This is gonna be 11 squared is equal to this one outside 7, and then the ones inside, and then x, then multiplied by 7. 11 square, I'm not gonna simplify it yet. This is going to be 12 plus x multiplied by 7. Now let's simplify. 1 to 1 is equal to 12 times 7 is gonna give you 84. 84 plus 7x. Therefore, 121 minus 84 is equal to 7x. Okay, so 121 minus 84 is gonna give you 37. 37, then we're going to divide both by 7. Therefore, our x is gonna be 5.28. 5.29, okay? 5.29. Okay, so let's just put that together. If we're going to recheck this one, it's just very simple. We have to put it in here, and we should get this one also, which is 11. So let's try that one. Let's put that together. So that's going to be 7 plus 5 is going to be 12. Okay, so plus 12, that's going to give you 17.285. Then multiplied by 7, voila, it's 1 to 1. Okay, so it's correct. So this is all for this lesson on angle measures and segment lengths. If you find this video helpful, share, like, and subscribe. Thank you.